Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So today what I'd like to do is just show you very quickly how the conic sections can be realized in the correct order, in the right order, one depending on the other and based on the properties of measure. Okay, so the very first one is really the plane or line. And unfortunately, when Apollonius wrote the conics, he didn't write a prologue, just like Euclid when he wrote the elements. He didn't write a prologue, so nobody understood what the elements was all about. They ended up with fake notions such as axioms, and they ended up tossing away the foundations because they couldn't understand things. And they built their own fake foundations called ZFC and set theory. So let's begin. Now, the first one that we realize is the plane or the line, okay? And that's basically just a magnitude. So it's a measure of a magnitude. That's all it is. Then immediately from the measure of a magnitude, we can get the hyperbola. Okay, the hyperbola is really the measure of one, or whichever the magnitude is, with another magnitude, okay, like this magnitude here. So one measures one, there should be one here, I think it is one. Yeah. On the hyperbola, one measures one exactly one, and two, you need two equal parts of 0.5 to measure one. All right? So we first need the line and then the hyperbola, because x measures one here, okay? X is 2, and it measures 1. X is 1.8, and it measures 1, okay? Because this here is an equal part of 1.8. So the next conic that builds on these two is the parabola, and it's this guy here, okay? Now, the parabola that we obtain in the conic sections is this one here, 1 minus x squared, okay? And I'll show you in a moment how that works. So to get the parabola, which is x squared, we have to measure x with 1 over x. In other words, we have to measure the line with the hyperbola, okay? The line with the hyperbola, right? So that's how that works. And then from those three, we get the circle, okay? And the circle is just that object whose radius squared is the sum of 2 squared. In other words, it's the area produced by parabolas whose sum is a constant square, okay? And that is the circle. Then you may wonder, how do we get that part of the parabola? Because I showed you this 1 minus x squared, and the circle here is in fact, this part of the circle is in fact the square root of 1 minus x squared, okay? So how do we find the square root? Well, once we have the circle already, we can find the square root using this property of the geometric mean, right, from the circle. And that means that if we have 0.6, we would multiply it, we would square it, subtract it from 1, and take the square root, and it would be 0.82, okay? And that would be the value that we would use to construct the circle, which is this guy over here, okay? And finally, we have the ellipse. Now, the ellipse requires square constants that measure the area of given parabolas, such that their sum is the same constant squared, right? So in other words, we have two parabolas, but they're measured by this a squared and b squared, and their sum is always the same constant squared. So in other words, this ellipse has eccentricity. And if it didn't have eccentricity, it would have this radius, okay? So that is a realization sequence of the conics in the proper order. and this knowledge has never been written down or recorded. So it's the first time I'm sharing this with you. You cannot simply, for example, decide you're going to realize the parabola before you realize the line or the hyperbola, because they're all measures based on the previous ones that have been defined. That's pretty much it. If you're not already a subscriber, become a subscriber to my channel. Click like, follow me on Academia.edu, and please note, I'm going to be starting a new channel soon, which is going to be for everyone, including kids, so it's not going to have any comments. And I'll advertise that channel once I've uploaded a few videos. If you're not a member of my members only channel, you can become a member for €4.99 a month. And I sometimes share knowledge on there which I've never shared with the public. So I encourage you to join my channel. I'm John Gabriel.